Hey everybody, happy Thanksgiving. Hope you're all having a great time with your family and friends. Today's video is a little special. I've been a game developer for upwards of 10 years now, and I'm finally ready to start teaching others. So, welcome to How to Develop Roblox for Idiots. Is that even the right term? So, you want to learn how to make games on Roblox, right? Well, where do you even start? How do you get better? What tricks do you need to learn to get better? All of it is really simple, and I'm skilled enough to be able to teach you guys, so why don't we get into it? The first main problem I see people having, including myself, is they play incredibly well-scripted games such as The Strongest Battlegrounds, Blackout, Deep Woken, or Pressure. They think that they can do the same that teams of developers can do. Well, the problem is even I have this mentality sometimes. It makes starting projects very, very difficult. Reminder, if you have any questions with game development or the channel as a whole, you can join my public Discord server on screen. Now to Chapter 1, Pre-Development. Looking to make games? Well, it's moderately easy if you know what you're doing. Let's start with some programs you need. All you really need is a good music app like Spotify, SoundCloud, or YouTube Music, or just ripped CDs, and Roblox Studio. You can get Roblox Studio by signing up for an account and hitting the Develop Now Create button on the top of your screen. Install Roblox Studio and you're done. Now, don't touch the templates, they're not terribly useful. If you want to make a good, successful game, you can't use templates. If you do it all from scratch, more people will play, and it will be much easier on your conscience knowing that you're not using content from other creators. There are two templates I would start with, the first being base plate and the second being my classic base plate. Why not flat terrain? Well, first off, the terrain feature kind of sucks, and second, we can make much more detailed maps with different methods I'll get to later. Before we begin development, we need to understand what we need on screen. Hit view, and there are a few things I like to have selected. Explorer, properties, toolbox, command bar, output, terrain editor, and view selector. I'll go over what everything in this menu means, trust me, it's not very complex. Now, let's talk about the four major tools and their variants. We have Select, which is used for dragging props around with your cursor. We have Move, which moves things along a specific axis. Scale, which grows or shrinks a part on an axis, or the whole thing if you hold Shift. And finally, Rotate, which rotates parts along an axis. This one is quite self-explanatory. Now, say you selected Rotate, why can I only change it in 45 degrees at a time? Well, to fix this, we need to go to Model and look to the right of Geometric. These toggles next to Rotate and Move, which are really simple. Imagine these as locks. When checked, they can only rotate 45 degrees at a time and move one stud at a time. When unlocked, they can move indefinitely and rotate as little or as much as you want. My ideal settings are 0.125 for move and 5.625 for rotate. These are the smallest measurements that can still add up to 90% things such as Z-clipping and such. Speaking of which, what is Z-clipping anyways? Well, Z-clipping is when two parts flicker back and forth because they occupy the same space. Now, if I were a normal person, I would be going through the model menu and saying, this is what X feature does and this is what Y feature does, but let's be honest, this gets confusing and you'll never end up using half of the important things. Plus, this is Roblox, development for idiots, not for mathematicians. So let's focus on the simple things. Unions are our next concept. What is a union? Well, go into models and place down a part. Selecting it highlights 3 of 4 options above solid modeling. Union, intersect, and negate. Let me explain each of them. Union binds two parts together, intersect destroys everything that isn't touching, and negate is the opposite of intersect, which destroys the parts that are touching. Once you select a union, the separate option pops up, which allows you to remove the two unions from each other. You may think unions are very useful for being able to use across different ideas from doors to windows to anything that needs a hole, but sadly it isn't that easy. Unions are laggy, and I mean really laggy, so avoid using them unless you have to. In this example, the white blocks are made up from normal parts, and the gray blocks are made up from a union. As you can see, there's visibly enough room for here to move in the gray hole, but it's acting weird. This is because the union collision is different from the props collision, which messes up the models. Avoid unions if possible, since the white one doesn't seem to have this issue. Now, a few more things to talk about before we get into the meat and potatoes of game development. If you want the old selection design from when Roblox was a bit older, I honestly prefer opening up View and go to the right, select Selection Style, and select Bounding Boxes. For modern, select Outline. My personal choice is selecting both, since it makes the lines thicker and easier to see. Another setting you can change mid-development is turning on grid material, which helps line everything up if you're OCD like me. If you want the materials, just select Show Grid right next to it and things will be a lot easier for you moving forwards. So remember how early in the video I told you to enable a few things in View? Well, it's finally time to explain them all. Explorer is the file manager menu. This is where all your scripts, props, and everything go. Everything inside your game, including your players, are held in the Explorer menu. Properties is the next major menu. This allows you to change specific things about a specific item inside Explorer. You can change the exact RGB levels of specific color, although I prefer to use brick color options picked for you in the dropper menu. You can also make materials more reflective, transparent, change their name, archive them, make them non-collidable. You can also change the shape, make props maskless, change the pivot, size, and more from one menu. You used to be able to make studded parts, but the feature is now deprecated. I'll explain what that means in a moment. After properties, we have the toolbox menu, which is used for people who don't know how to code. I do not recommend using this, although I do make my own props and save them to the toolbox for ease of access. The toolbox allows you to find models, plugins since it's not used in the create menu anymore, I'll explain what those are later, audio for sound effects and ambience music, decals for images, mesh parts for things like, I don't actually use meshes, it has something to do with Blender, videos for videos and fonts for fonts, all these are self-explanatory. Command bar is for running commands like instance.new to spawn different props and code within the Explorer. Output displays any errors and print functions sent by the scripts. Terrain editor allows you to use modern terrain since classic terrain is deprecated. Finally, view selector allows you to change your camera to snap to a specific axis. Now we can finally talk about a few more things before we get to scripting. I know it's boring in the beginning, but trust me, it doesn't get much more fun from here, so enjoy this because it will get a lot more frustrating. Let's talk about what's actually in Explorer. Workspace is where the main gameplay is. Imagine it like a play. Workspace is the current scene where everything is projecting onto. You need proper lighting to make the workspace look good, you need players for the characters, materials for the immersion, and scripts to have it all run properly. Players contain all the player objects including data, inventory, and character models during gameplay. Lighting controls the environment settings like time of day, ambience, and other visual effects like bloom and field of view. Material service holds all the custom materials that aren't preloaded into the game. Replicated first stores objects that are loaded by the client first when the game starts, hence the name first. Replicated storage is for objects that need to be accessed by both the server and the client. I'll get into the differences after this. Server script service stores server scripts and modules like game logic and data handling. Most server-side functionality is held in server script service. Server storage is the model version of server script service, which holds objects that should only be accessible by the server, such as models that the client should not be able to access. Starter GUI holds the GUI, or graphical user interface, such as menus and buttons, health counters, etc. Starter pack stores objects that are automatically added to the player when the game starts. Starter player contains settings and objects that are specific to each player, like walking animations and player models. Within Starter Player are two different folders, Starter Character Scripts and Starter Player Scripts. Starter Character Scripts are scripts that are supposed to run on each player's character, the 3D model instead of the actual player. Starter Player Scripts, however, store scripts that run for each player individually and run on the client. Things like cutscenes need Starter Player Scripts. Teams are an older feature, one of the first truly unique features on Roblox. This allows you to have different classes, spawn locations, different weapons, clothing, and everything based on what team you're into. It also automatically separates the leaderboard. While it's an old feature, very good games still use it like Dark Divers. Sound Service Manager manages all the sounds within the game, like ambience and sound effects. You will not use this much as a beginner. Text Chat Service you literally will never touch. I have never used it in my years of game development. Now, as mentioned earlier, what are the differences between client and server? Well, imagine it like this. The client is your computer that can communicate with the server but can't modify the server. The server is the computer running the game. This has access to all of the code, including things you don't, because it's the actual game. The server and the client cannot interact unless you use remote events. This is oversimplified, but again, this is Roblox for idiots, not for geniuses. Now that you know the basic features of Roblox Studio, how about we get into scripting? Well, there are 3 different types of scripts you need to know before we continue. Local scripts, server scripts, and module scripts. Don't worry about module scripts as a beginner, I still don't fully understand them. Local scripts are client-side and server scripts are, well, server-side. Both use the same coding language of Lua, which makes things easier. Let's get into our next chapter, the basics of coding Lua. Coding Lua is pretty simple, but before we begin, we gotta figure out what we want to make and how we want to make it. How about we make a door? First, we need to make the actual model, which is pretty easy. Make sure it's all anchored and select every piece of the door, right-click and select Group. Make a button for each side and name them Button 1 and Button 2. Group these together as well, and then the door frame. Group all of these into one folder and make a script inside. There are 3 different ways we can make the script. We can use a button that we press with our cursor like in Innovation Labs, a GUI that pops up and allows us to open doors like in Criminality, or an on-touched function that automatically opens doors like in Kaiju Paradise. Now, there are 2 concepts you need to learn before you continue: functions and defining. To define a specific part in the game, we need to use local door equals script.parent.door getChildren. What this does is it gets all the children from the door model. We do the same since the buttons are connected to the door. Now we can go down and I'll explain what each of these things do. We need to type function move door parenthesis offset, then for underscore comma part in pairs door do. If part is a base part, then part.position equals part.position plus offset. This may seem very scary and confusing, but it's actually really simple. Let's break it down. Function moveDoor offset identifies 2 terms, moveDoor and offset. We can define the offset later on and change how far the door moves. MoveDoor is the command we will use to actually move the door. For underscore comma part in pairs is getting all of the parts of the identical door model, and if part is a base part, then is checking if every part is normal. That way we don't throw errors by accidentally trying to move lighting objects or scripts which don't have a model attached. We do the same to all of this for the button. Now, we need to decide which to use. For this example, I'll be using proximity prompt, but the rest can be substituted really simply. To make a proximity prompt, you can go into the button model and make a proximity prompt. Do the same for the first one, and go back to the top of the code. Now we identify the proximity prompts. prox1 equals script.parent.buttons.button wait for child proximity prompt. And we do the same for prox2. Why do we do this? Well, if we define our proximity prompt before it loads, it can bug the door and prevent it from ever working. Now under activate, we disable both of the proximity prompts. Why? Well, if we don't, the player can spam the door. Now we get into moving the door. Type I equals 1, 85 do wait, move door vector 3 dot new, 0, 0.075, 0. The reason why we do wait is so it doesn't run on the fastest tick rate it can, which is in a singular frame. It will crash the game, so we need the wait statement. Then we do vector3.new because we're inputting what coordinates we should move it by. Then we wait a second, and prox1 is enabled to true. Now we have 2 different things we can do. The door automatically closes, or we set a value to allow it to be opened and closed by the user on command. The latter is more interesting, but if you want it to automatically close, add a wait statement and then just subtract the same amount of coordinates. If we move by 0.075, do negative 0.075 in the vector3.new, if that makes sense. Go to the top and type local open equals false, being it's currently closed. Go to the top of activate and type if open equals false, then, and copy all of your code into there. Make sure the first thing it does is sets open to true. Now open a line before the if statement ends, and type else, and then copy your code over again. Now if we try it, it should work flawlessly. See? The only problem is, when you use it again, it goes into the ground. Why is that? Well, we need to go back in our code and set open to equals false in our else statement. And congratulations, you just made a door. This also brings us to the end of the video. Thank you for watching. I had a lot of fun making this video, and even though it's a bit lower quality than the rest, I still think I did a good job on it. I hope you all learned something today, and as always, the Discord server is always open if anyone would like to join and ask me questions or discuss my upcoming content, or even if you need someone to play a game with. As always, I hope you have a good rest of your day. Ciao!